Hello, everyone. I hope you can hear me okay. Welcome to Touch Tank Tuesday. My name is Olivia, and I am the Education Coordinator here at the Deep Bay Marine Field Station. I'm very excited to talk to you about our creature today. Some of you may have seen it as we were getting started here. And you might actually have guessed what it is. If you do know what critter it is, definitely pop it into the comment section and I'll be able to see if you've guessed what it is. Before we begin, the Deep Bay Marine Field Station is an education and research facility that is part of Vancouver Island University. A lot of our research focuses on shellfish and shellfish aquaculture, and our education focuses on our local marine environments and how we might make an impact on our local and global environment. So let's get started. So if you haven't guessed it already, this is Lewis's moon snail. It's a species of moon snail. And as you can see, it's really cool looking. Let me know what you think about it in the comments section, and hopefully I'll be able to see your comments here. But we will talk about Lewis's moon snail. First, we will talk, moon snail. It is. Very good. Good job, Michael. Michael got it. It's a moon snail. It's a really big moon snail. And so today we'll talk about moon snails. Just in general, we've already had a couple sessions on different types of sea snails. So we'll talk about this one, we'll talk about sea snails in general, moon snails in general, and then we'll talk about Lewis's moon snail that's right here. If you have any questions, please put them in the comments section and I will hopefully answer them for you live. If I don't see them or if I can't answer your question, then I will come back and go into the comments section to hopefully give you a pretty good answer. Okay, but definitely feel free to ask your questions. So let's get started. Moon snails are sea snails. So sea snails, if you remember, they're in that big group mollusca. And that's basically any of these invertebrates that are soft and live in a shell usually. And they'd include things like scallops and oysters that we've already talked about. But then they do divide into the class. So while oysters and scallops would go into bivalvia because they have those two shells, the snails go into gastropoda. And so that's where you would find marine snails, slugs, and also have terrestrial species, obviously. But we can further look at more marine species by going down to the order, Littorinomorpha. So this order has mostly marine species of snails and slugs. There are still some terrestrial or some freshwater species in that order. But when we say moon snail, we are talking about the family Naticidae. So the family is called Naticidae, and there's about just under 300 species, and you can find them worldwide. So moon snails can be found all across the world. Here in the Pacific Northwest, at least in my species guide, there are 5 species of moon snails. And they live in the intertidal zone. So at least with Lewis's moon snail that we have here, it doesn't go very deep. Usually it goes to about 50 meters depth. So that'll be your intertidal zone into the bay here at Deep Bay. So it won't really go too far or too deep into the subtidal zone. And so yes, it's worldwide. And they do tend to live in more sandy areas. So you'll find them in the intertidal zone where there's lots of sand because they actually bury into the sand. So they'll be deep and actually hard to find. So if you've seen some of our sessions before, I've talked about the moon snail, this amazing critter, and how I couldn't find it. I knew that we had one in our touch tanks, but I couldn't find it because it buries itself into the sand. So sometimes you might see the sand sort of lump up a little bit. So there might be a mound, and that moon snail is in that mound. So that's how I found our moon snail today. And this snail is actually new to our touch tanks. A couple of my colleagues went out collecting in the intertidal zone on our beach lease, and they did find this moon snail. And this moon snail is unusually big. So We'll talk about it here. I will make it a little bit bigger so that you can see it, but hopefully you can still hear me. But you can see this is the shell of the moon snail. And what you would expect if you picked it up would be that it could take its whole body into its shell. But this snail is actually so big. I'm just lifting. It's very slippery. So this snail is so big that it actually doesn't go all the way into its shell. But if it was a little bit smaller, as they usually are, it would come into its shell. And it also has an operculum. If you remember, the operculum is that sort of trap door that shuts. And that's how it stops itself from being eaten or from predators trying to take it. That's one of the ways it stops them. So that's a feature that it has that's similar to other sea snails. It has actually a bunch of features that are similar to other sea snails. You see they have the big shell. So this is big, hard calcium carbonate shell here. Then this is the pedal foot. So that's a big mass of body, and that's usually on the underside, and it's inside this spiral whorl chambered shell. And so this shell protects it from the environment and from predators. So this is that pedal foot. As you can see, it's quite a bit bigger than most sea snails might have, and we'll talk about that soon. And so it also has the tentacles, which you aren't seeing right now, but you can see them poking out over here. I will leave it alone for a minute. I'll point them out. So these are rhinophores. So they are what they use to investigate their environment. They have chemoreceptors. So that means that they receive those chemicals in the water to sort of see their environment. And that's how they find their prey. Here you go. This right here that's poking out. And I will move this over for you to see. And that's very similar with other species of sea snail that we've also seen before. You can see it poking here. And it goes back in. So let's see if this is better without the light. It is. So you can see it a little bit better. And there you go, it's sticking it out. So it has two of these, and it uses them to sense the environment. And then it's also similar to other sea snail species because on the underside, if I were to flip it over, it has something called a radula. And remember, the radula is this mouth. Ooh, look at it right now. If you can see it moving, there we go. See, it has stuck both of these tentacles up out of the water, and it is sensing. It's moving them around to figure out, hey, what's happening here? Why am I the star of this show? So you can see those there. And so it has that radula on the underside in its mouth. And if you remember, the radula is like a conveyor belt. It's its teeth. It helps it to eat. This is a predatory snail. So it is an amazing predator. And as a predator, it needs that radula to scrape and chew. And so these tiny chitinous, so that's what it's made of, chitin, these tiny teeth will scrape, 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 and that helps it to eat. Now, these are really fantastic predators because they not only do they use their teeth to eat, but they also secrete an acid. So there's an acid that helps break down their prey. And what happens, you can see that it's actually moving away from you right now, but it is a very fast snail. So I'll zoom out for you because you've already seen the tentacles. So what happens is that the moon snail will, this is a shell that has, well, a clam that used to be alive, but you can tell that it was eaten by a predatory snail because of this hole that is in it right here. And that hole is a drill hole. So I'm not sure if this was a moon snail that ate it or if it was a different species of predatory snail. And remember, we looked at the Oregon Triton a couple sessions ago, and that's a different type of predatory snail. And so this is the drill hole. But what's really unique about the moon snail is that the moon snail will secrete an acid to help it. So some of those thick shells, it would even take some of those bigger clams. It helps dissolve its way into the shell. Once it breaks through the shell, it will suck up all of the tissue that's inside, so the organism that's hiding in that shell and protecting itself, and then it will release the shell, and that's why you can actually find them out on the beach, which is pretty cool. Okay, so that's how it's similar to other species of sea snail, but it's actually quite different, as you can tell just looking at it. Look at that petal foot. It is huge. So what a sea snail or a moon snail does is it has this vascular system, a water vascular system. And this vascular system fills up, so you can see it expands by taking on water. And then if it's disturbed or scared, it quickly shoots all of that water out. It will shoot that water out so that it can pull its body into its shell. And then when maybe the predator or the disruption's gone, it will fill back up with that water. And maybe I'll split here. There we go, so you can see me. So it will expand like this, pulling the water into its foot. And then if it's disturbed, it will it will push all of that water out very fast, actually. So it pushes all of that water out, it goes into its shell, and it hides. So this snail is really cool because it can move pretty fast as well. It moves by the same way that most sea snails move, by contracting and releasing its muscles to create sort of a wave-like motion. And so if you go out into the intertidal zone and maybe it's caught the scent or the chemical scent of a clam in the intertidal zone and it's going to go for it, you can see it plunging through the sand. So you might just see a little bit of the shell at the top and then the body coming out, and it will be plunging through that sand. So it's really, really cool to see. Another thing is really cool to see, and maybe I'll be able to get a video of this in the future, is if there's a cockle or a different type of clam that if you put it in one place, it's really cool to see the defense mechanisms that that clam has. Oh, hey, Lisa, thanks for joining us. It's really cool to see some of the defense mechanisms that that snail has, that clam has. It might even get its foot out to try and help itself. The moon snail does not have a lot of predators. So a lot of the time it eats clams, it eats different types of shellfish. Sometimes it'll eat crabs, but mainly it tries to eat clams. And so that's why it's actually, we find a fair few of them here in the intertidal zone, because we have a lot of clams and different shellfish on our lease. And so that's what the moon snail eats, but it doesn't have a lot of predators. You can see it's kind of too big for a lot of species that are out there. It's way bigger than my hand, so its whole body. So usually it might just be a sea star. A sea star might eat them. They have been known to be consumed by people. So people have eaten them in the past as food, but it's not really suggested. I don't think that they are collected. They're definitely not collected as a commercial species, and I don't suggest eating them on your own, because what can happen is that as they consume clams, they can also accumulate and consume different toxins from those biotoxins from those clams from eating too many of them. So maybe a different time of year, if there's an algal bloom, then they might actually absorb some of those toxins. Yeah, and so one of the cool ways that it escapes some sea stars is that it starts to actually eat the pod feet. So remember the tube feet that come from the sea star, and that's how they move and how they suction on to different surfaces. So if that sea star is crawling up on the moon snail, what it'll do is it'll take its radula, so its mouth, from the underneath, and it will start to actually eat its feet and then break free from that sea star. And there's not a lot of sea stars that would eat it. Maybe I think it's the sun sunflower sea star. I don't remember what name it is, but there is a sea star that will eat it if it doesn't get away from it. I'm not sure if we'll actually be able to see. It's very slippery, so I might be able to turn it over for you to see. Well, you can see sort of the tissue here from its feet. And here's sort of the underside. I can't really see its radula here. But that's okay. I don't want to disturb it too much. So you can see that I've disturbed it actually a lot. So with this, usually with a moon snail, with this disruption, what will happen is it'll push all of that water out. It'll suck itself into its shell. But for some reason with this moon snail, either it is too big for its shell, so it can't fit. Clearly it's eaten too many clams, or there's something wrong with it in that it's not able to purge that water from its foot, because I think I've scared it enough. And that's how much I'm going to explore the moon snail right now, because I don't want to upset it too much. It will go back into our touch tanks and be there for the rest of its life. So it will be part of our touch tanks. So when we do, oh yeah. Yeah, Lisa has said that she's touched one in the intertidal zone at low tide, which is definitely where you're going to find them, and that it is really slippery and slimy. It is. It's so slimy and slippery when I'm trying to grab it. Usually I wear gloves if I'm going to pick it up. I'll just come out a little bit so you can see the rest of it here. And so there it is. Does anyone have any questions? I think we've touched most of it, other than, oh, maybe the reproduction. So there are females and male moon snails. The females are a little bit bigger. Apparently they have a bit of a thinner shell, though the shell wall is a little bit thinner for the females. So there is a little bit of sexual dimorphism. So remember, that's when the male and the female within a species look a little bit different or behave differently. And so that's how they're different. Yes, it does have a beautiful shell, and I've actually seen a lot of shells that are out there that, and we have a couple shells in our touch tanks. A lot of critters love to live in them, so they make a great habitat after the moon snail has passed. So that's pretty great for them. Some hermit crabs go in there, but I don't think we have a lot of hermit crabs that could live there. Maybe hiding there within their own shell, but maybe they're not big enough to truly fit in this shell. And so they reproduce, so their reproduction, so they do produce eggs, and when those eggs are fertilized, they actually end up living in the sand. So when, oh Jan, that's a great question. Just a moment. So when those eggs do hatch, they get pushed out of the sand by some currents, so that sand will move. They'll end up in the water column as larvae, and they'll mostly be eating different types of algae. Maybe they'll be eating diatoms while they're in the water column, and then they will grow and settle and become juveniles and then predatory snails. So that's how they end up growing. I actually don't know how long they live. So Jan has asked how long they live, and I do not know. So I will check and come back to you, and I will reply to your comment afterwards, because that's something that would be really interesting to know. This is Lewis's moon snail, and remember, there are 5 different species that are, at least in my species guide, that live in the Pacific Northwest. This is the only species that I have seen. I'm not sure if any of you have seen any different ones, but here in Deep Bay, it is the most common one that we've found. Does anyone have any more questions? Hi, welcome. Yeah, it seems like some people are coming in a little bit later, so I might actually go over some things that we talked about at the beginning, just for fun. Oh yeah, have you seen them? Okay, so Lisa said that she saw the egg collar, and so that's basically it looks like a shirt collar, and it's a row of eggs that are from the moon snail. Yes, and she thought that it was a byproduct of maybe something human-made, maybe man-made, and so yeah, they definitely are very weird. They look like egg sacs or these almost like plastic. It does look very strange if you've seen them in the intertidal zone. So I will just kind of run through sort of what we talked about in the beginning. So the moon snail is a predatory snail, unlike the limpets that we talked about. Remember, limpets are more herbivores. They will be eating algae, but this is a predatory snail, and it's a very cool predator because it is amazing that it can just eat anything it wants. Apparently, in a laboratory experiment, if you have a moon snail, it can eat one large clam every 4 days. So it spends a lot of time using acid as well as its radula. Remember that row of teeth that are made of chitin that are inside the snail. They will kind of move like this, and that scrapes and scrapes and scrapes. So they drill a hole into a clam, but they also use acid. So they'll secrete acid into that shell. And so it'll take them 4 days to fully eat a clam. And so they're more like, so the limpets are those herbivore, maybe algae eating sea snails, and then the sea snails like this moon snail are kind of closer to the Oregon triton that we looked at before. Yeah. Does anyone have any more questions? See if anyone does. Moon snails are in a family. They can be found worldwide. This family is it's about 270 living or recent species in that family. Yeah. So how long? Lisa's asked how long it would take to drill the hole into the clam shell. So I think it would take most of that because it doesn't take a long time to actually absorb the food. So I think it probably takes most of that 4 days to drill through the clam. Yeah. Yeah, it's the acid. Very good. Yes, Jan. So they create that hole. I have misplaced my shell. There it is. Okay, and remember this shell here. So these holes are from predatory snails. And so it will drill with its radula, but it will also use acid to do the final drilling and to sort of kind of dissolve it. There we go. It'll dissolve the shell. And that shell is made of calcium carbonate. So that's something to think about when we think about ocean acidification. As the ocean, as the pH kind of drops in the ocean and we have water becoming a little bit more acidic, it might affect different species that have calcium carbonate shells or use calcium carbonate. And they can affect them at really different parts of their lives. So we even have this moon snail, for instance, that uses acid to drill through calcium carbonate. So it is quite amazing. Yeah, it's perfectly round. And you can see that in a lot of different shells if you actually, I'm sure you have, Lisa, in the intertidal zone here at Deep Bay since you've been here. Yeah, it's absolutely amazing. And I will try and get a video of the moon snail maybe coming at a clam, and it'll kind of show you how fast the moon snail is. I could not find any clams this morning to show you how fast the moon snail is. And it'll also show you how the clam actually defends itself. Because not only does it have its shell, so now we have this predator, this amazing predator that can get through its shell, so that shell is not going to help it, right? So it needs something else to help protect itself. And so it's developed a behavior to help protect itself. And it has to do with its pedal foot as well as shooting water. So it's quite cool. Yeah, I will try and get a video of that either this week or next. And I will be posting it then on our Facebook and hopefully onto our Instagram then. Okay, well, everyone, thank you so much for joining me today. If you have any more questions about the moon snail, please post them in the comment section. I'll be happy to come back and answer them as soon as I can. And if you have any suggestions for what you might want to see next week in Touch Tank Tuesday, I would love to have some suggestions. And if you don't have any suggestions, then I will come up with another exciting critter for you to see. But thank you for joining me, and I will see you next week.